Welcome back, everybody. We are going to be covering sections 4.1 and 4.2, talking about polynomials. So, a polynomial is defined by the degree, leading term, and leading coefficient. So that degree is just our biggest power, or our biggest exponent. Our leading term is the number with the largest exponent, so number and x with largest exponent. Our leading coefficient is just that number with x, with our largest exponent. And then our constant term is the number with no x. And so for all polynomials, our domain is going to be from negative infinity to infinity. And the graph is going to be constant and smooth. And so basically what this means is that there are no jumps in the graph, there's no asymptotes, there's no holes. That's what we mean by constant. And so if we look at this first example, we have f of x equals x, 3x to the 5th power minus 4x to the 4th plus 8x minus 9. And so a lot of what we're going to be looking at is our leading term. So our leading term is 3x to the 5th, which means that our degree is 5, our leading coefficient is 3, and then our constant term is negative 9. So our constant term is really important. This is going to be our y-intercept. And so the end behavior, this is the part of the function that refers to the graph as x goes to infinity and as x goes to negative infinity. So this notation is what MyMathLab uses. We will just be using, for example, if we have this graph that looks something like this, what we want you to say is that our end behavior is up, up, but how MyMathLab will want you to write this is as x approaches positive infinity, so that's this portion of our graph, y approaches positive infinity, and then as x approaches negative infinity, which is this part of our graph, then y approaches positive infinity in this case. So if we're going up, up, this is how MyMathLab will want it. If we have a graph that looks something like this, then how we would want you to describe this is that it's down, then up. And so as x approaches infinity, so that's going this way, y approaches positive infinity, and then as x approaches negative infinity, so that's going this way, y approaches negative infinity in this case. And so our leading coefficient tells us our end behaviors. This should. So we look at the positive or negativity of our leading coefficient and then also our degree. So if our leading coefficient is positive and our degree is even, this means that we're going to be going up. Up is our end behavior. And if we have that it's positive and odd, that means that our end behaviors is down, up. And if our leading coefficient is negative and even, this means that we're going down, down. And if it's negative and odd, we're going up, down. And so some shortcuts for this is that if we have an even degree, these are going to end in the same direction. So same direction. So either up, up, or down, down. Or if it's odd, it's going to be in the opposite direction. And if we have a positive leading coefficient, that means that it's going to end up. And if we have a negative leading coefficient, that means that it's going to end down. So if we look at our rightmost end behaviors, that's what I mean by that it ends up or ends down. So if we look at this example, our leading coefficient is 3x to the fourth, so this means that we have an even and it's positive. So our end behavior is going to be up, up, which means that it would be graph D. If we look at C, our leading coefficient is positive and odd. So that means that it's going to be down then up, which would be graph A. Then for B, we have that it's negative 5x cubed. So this is odd and negative, which means that our end behavior is going to be up then down, which is graph B. And then we have for graph D, or for function D, we have that it's an even degree and it's negative. So this means that it's going to be down, down, which would be graph C. And so we will talk about multiplicities in class. So go ahead and skip those. And we will also talk about graphing in class. So go ahead and skip to the intermediate value theorem. And so what this says is that for any polynomial function with real coefficients, if A and B have opposite signs, so what that's saying is that if we have a graph and we have points A and B, so if P of A is up here, P of B is down here, this means that at some point in between, we're going to have a value C such that P of C equals 0. So basically what this is just saying is that if we have two values that have opposite signs, so one's positive, one's negative, somewhere between those points, we're going to have a 0. So for example 5, it says determine, if possible, whether the function has at least one real 0 between A and B. So what we're going to do is we're going to take f of negative 4, which would be negative 4 cubed plus negative 4 squared minus 6 times negative 4. So if we type all of that in, we see that this is equal to negative 24. And then if we do f of negative 2, this means negative 2 cubed plus negative 2 squared minus 6 times negative 2. This would be a positive 8. And so because they are opposite signs, then we have a 0 between negative 2 and negative 4. It might be negative 3, but it doesn't necessarily have to be exactly in the middle. It just means that somewhere in between -4 and -2, we have a 0. And then if we do part B, again, we want to take f of -1. This would be -1 cubed plus -1 squared minus 6 times -1, which would be a positive 6. And then f of 3 would be 3 cubed plus 3 squared minus 6 times 3. And we see that this is a positive this would be positive 18. And so since they have the same sign, we do not have a real 0 between -1 and 3. So, thank you guys for tuning in, and we will see you in class.